Welcome to solving quadratic equations for Pre-Calculus Math 11. Today we're going to take a look at factoring polynomial expressions, which is section 3.1 from our book. Last year you spent a large amount of time factoring expressions. Very important to be able to factor. What this section really does for us is we're going to review those techniques, but also we're going to build on them a little bit. I want to amp up the questions a little bit, see how they apply to other type things. The first thing I want to look at here, I think, is this idea of, is a certain binomial a factor for a polynomial? Now, what we're going to do is we're going to assume that maybe it is. We're going to assume that the binomial m plus 2 is a factor of this. Let's factor it. What's the other factor going to be? I don't really know. So let's call that other factor am plus b. I'm going to use the letter a and b as unknowns in this case, unknown coefficients. And what we're going to do is we're actually going to FOIL this out. So FOIL is first, so am squared. We have m times b, so let's call that bm. We have 2am for the insides, and lasts would be 2b. So when I FOIL this out, I get am squared plus bm plus 2am plus 2b. What I want to do is let me write down my given equation, 3m squared plus 7m minus 6. Now you'll notice that this am squared and 3m squared are the only terms with m squared. Also, the 2b and the negative 6 are the only terms with no variable in this case, no variable m. So what I'm going to do, we're going to always look at those last two, or the first term, the m squared term, and the constant term. What we can do is we can create a little equation. Am squared has to equal 3m squared, and we see that a has to equal 3. On the other end, 2b has to equal negative 6, b equals negative 3. So we know that this only works if a is 3 and b is negative 3. So let's see if this actually works for our polynomial. What has to happen is that the bm plus 2am, that middle term, has to equal 7m. And that's what we're going to test. We know b is negative 3. We know a is 3. That's negative 3m plus 6m. And what we get is positive 3m, which definitely is not equal to 7m. So this answer is a resounding no. So in this case, m plus 2 is not a factor of 3m squared plus 7m minus 6. So compare the first term, compare the last term, find out the a's and b's, and solve for the middle. Maybe take a second, follow that pattern, see if you can do this second example. So again, we're going to go m plus 2, am plus b. I'm going to speed this up a little bit. We have the am squared plus bm. So that's again just FOILing out. We have the original equation here is 2m squared, 7m plus 6. Those two terms have to be the same. And we got am squared equals 2m squared, so a has to equal 2. We have 2b equals 6, so b equals 3. And now we're going to check if it really actually works out with the middle term. And we're going to go with bm plus 2am. Figure out what that equals. 3m plus 2 by 2m. And we get 7m, which does equal 7m. So yes, this one certainly does work. So m plus 2 is definitely a factor of that second equation, 2m squared plus 7m plus 6. So that's more of a reasoning thing. Probably a worthwhile endeavor to understand what's going on there. We might come back to that in class. In a perfect world, we would only have to factor expressions with integer coefficients, so a 2, a 3, a 4. But we need to develop techniques for when coefficients are other rational numbers. So certainly decimals. Decimals are a real problem. but they are a rational number. Let's just say because of decimals, let's factor out, and in this case we have a decimal of 0.9 and a decimal of 0.6. Let's factor out a 0.1 out of that whole equation first. That's one way that we can get rid of any kind of decimals. So factoring out 0.1, when you pull 0.1 out of x squared, you're effectively dividing by 0.1. That's going to make that 10x squared. 1.9 divided by 0.1 is 19. And 0.6 divided by that is 6. So you may recall a technique that you use to factor concerning the a, b, and c value in this case. So we have a equals 10, b equals 19, c equals 6, really just the coefficients of each of the terms. You may recall the multiplying a times c, in this case 10 times 6, which is 60. And what we're going to do is we're going to look for factors of 60, that potentially add to our b value, in this case our b value of 19. So let's just table off the factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, I think pretty well does it. And again, it's going to be the plus or minus versions of those. We need to look for a sum of 19. Again, 19 because that is our b value. So it looks like the 4 plus 15 will give us our 19. So what do we do with this information is we rewrite the equation, in this case 0.1 10x squared. The 19x we actually break up in those two numbers. We break them up into 4x and 15x. And we still have the constant of 6. The reason why we break this up is now we can group factor. So the 10x squared we group with 4x, just the first two. Actually didn't matter what order we wrote it in. 15x gets grouped with 6. We do that so that we can factor out greatest common factors. Out of 10x squared and 4x we can pull out a 2x, leaving us with 5x plus 2. Out of 15x plus 6 we can pull out a 3, leaving us with 5x plus 2. You know you've done this technique right when you see that common 5x plus 2. What we actually do is we actually factor out 5x plus 2 out of the first term and the second term, leaving us with a 2x and the 3. So there we go. That is a factored expression for a quadratic trinomial that has integer coefficients, or sorry, not integer coefficients, but rational numbers have coefficients, in this case a decimal. If we take a look at the next example, we see fractions. So let me show you the quick little step we're going to take to deal with the fractions. Certainly because of the fractions, what we're going to do is let us factor out the lowest common denominator, which in this case is 1/2, since we only have one fraction. When I pull out a half, again we're dividing by a half. The x squared term becomes 2x squared. The linear term remains an x because we pulled out a half, and the 3 becomes a negative 6. What I'd like you to do is hit pause here and factor that trinomial using whatever technique you'd like. Okay. Because this trinomial has a leading term of 2, another way we can do it, I'm going to not do it the way that we did it in the last example. I'm going to show you a little bit of a different way, which is a little bit more conceptual. This is a fairly straightforward trinomial to factor, only because the first term, which is 2x squared, is a result of the first two terms in the brackets multiplying. So our options are pretty limited. It has to be a 2x and an x. We don't have terribly many other options here. Where the real thinking comes in is the 6, which must come from the last two terms. We have options here. So the 6 could have come from 6 times 1, or a plus or minus 6 plus or minus times 1. It could have come from 2 times 3. So we actually have two cases. What you might want to do here is, because the coefficients of the x's are 2x and x, you might want to just start thinking about, well, in your head almost, multiplying these coefficients times each of the groups of the factors of 6. So 2x times 6 would be 12x. X times 1 would give me 1x. So 12x and 1x, you know what? These are all supposed to combine to give us negative x. If we go 2 times 1, that gives me 2. 1 times 6, that gives me 1. Well, 2 and 6 can't combine to give me a negative 1. Let's try 2 times 2 is 4. X times 3 is 3x, so 4x and 3x. Oh, if I somehow subtract 3x minus 4, that should work. So it should be the x times the 3 and 2x times the 2. And let's just figure out what the sign has to be. 2x times 2 has to be negative 4, and 2x, the 3 times x, has to be the positive. Now, that is a very conceptual way to factor it. I'm not saying that you need to be able to do that. Certainly, you could factor it the old way, or not the old way, the way that I did in the previous example, and I would be more than happy for you to see that. If you'd like to talk about this technique I just kind of did here, I didn't really write too much down because a lot of it was in my head. Feel free, let's talk about it in class. Moving on. Our techniques for factoring quadratic trinomials can also apply to higher degree. So higher degree expressions, as long as the expression contains a constant term as well as two variables in them. So higher degree equation, right now we're dealing with quadratics, x squared. I'm talking about any higher degree, x to the 4, x to the 6, whatever. It should still work with a few little things that you have to check. Normally when we factor this, the expression has an x term and an x squared term. But the technique will still work as long as the power of one of the terms is double the power of the other term. For instance, x to the 12 plus 7x to the 6 plus 12 will still factor fairly easily because x to the 12 is double the 6. So anytime that leading term has a power which is double the middle term, this will still work. Our factoring will still work. So for instance, if we want to factor x to the 12 plus 7x to the 6 plus 12, again, the first term has to multiply to x to the 12. The two numbers that multiply to x to the 12 are x to the 6 times x to the 6. Now we're going to figure out what two numbers multiply to 12 but add to 7. That's going to be a positive 3 and a positive 4. So we see that this factored very similarly to a quadratic expression, but in this case it's actually an x to the power 12 expression which is factored. Why don't you see if you can do B? So in question B, we have two factors. The first terms must multiply to x to the 4, so we can go with x squared times x squared. We need to multiply it to negative 15 in this case, so one of them has to be positive, one of them has to be negative. What multiplies to negative 15? Let's see here. We have 15 is 1 and 15, not 2, 3 and 5. That's about it. So must be 3 and 5. We want 5 to be the positive, and we want 3 to be negative. So again, we took factoring quadratics into a little bit of a higher level, a little special case, but certainly works.